Okay, so this is 9.6 log properties, logarithmic properties. I don't know. I don't know how to say the word logarithms. Logarithms. I just say log. Okay, so we can use log properties to expand and condense log expressions. So basically what we're going to be doing today is we're going to be given an expression and we either have to condense it or expand it. Condense it means like make it shorter, or expand it means make it longer. And we do that by using our 3 log properties. So there are 3 main log properties. So the first log property is about products or multiplying. So let's say if we have the log of m times n, I can expand that to log m plus log n. Okay, so when they're being multiplied, we can expand them to addition. Okay, now the next one is the opposite. If we have log of m over n, so now they're being divided, instead of it being addition, it's going to be log m minus log n. And notice specifically that m is at the top and it goes first, and then n is at the bottom, it goes second. Okay, so when it's division, it's subtraction. The last log property has to do with exponents. So if we have something like log m to the power p, what actually happens is we take this exponent and we move it to the front. So I can rewrite this as p log of m, okay? And these are our 3 log properties. So we're going to use these 3 rules now to help us either condense or expand. So we're going to first talk about condensing. So let's write that here. Condensing logs. Okay, so we're going to do 3 problems. First question. Let's say I have d log a minus 3 log c. So we want to now condense this, meaning we want to rewrite this as just 1 log. So there should only be 1 log. So when you're condensing, the first thing you want to do is move back your exponents. Okay, so we're going to be using this last log property, right? Which basically says if we have an exponent, or if we have a number in the front, we can move it back to the exponent. So d is going to go back and be an exponent of a, and 3 is going to go back and be an exponent of c. So I can essentially rewrite this as log a to the power of d minus log c to the power of 3. So I've used this exponent log rule. Now I can condense this even further, right? Because I have this minus sign here, right? And if we look, we know that if there's a minus sign, I can condense it and use division. So I can condense this even further and say I can rewrite this as log parentheses a to the d over c to the 3rd. So I have officially now rewritten this as 1 log, okay? So let's do a second problem. Let's say I have 2 log c plus y log d. First step, gotta move your exponents back, right? We're trying to rewrite this as 1 log. So I can rewrite this as log c to the power of 2 plus log d to the power of y. Now I can condense this even further, right? Because there is a plus sign here. And I know that I can condense this and multiply the 2 things. Essentially, I'm multiplying the c squared and the d to the y. So I can rewrite this as log parentheses c squared times d to the power of y, like this. And I have now rewritten this as 1 log, okay? Let's do one where instead of variables, we actually have numbers. So problem 3, let's say we have 2 log base b of 4 minus log base b of 8. First of all, we can only use these properties if they have the same basis. So we are good here because they both have a base of b. Same thing, I'm going to start by moving my exponents back, right? So I can rewrite this as log base b of 4 squared minus log base b of 8. Now I'm going to simplify this. 4 squared, 4 times 4 is 16. So log base b of 16 minus log base b of 8. Now, because it's minus, I know that I can divide the two things. So I can rewrite this as log base b of 16 over 8. And this can be reduced to log base b of 2. So this is my final answer. So try the questions of condensing, and then you're going to watch another video on expanding.